grab this link. So 3.5. So I recorded the lecture over 3.5 and posted that to Blackboard. If you haven't had a chance to watch it, you should watch it. Some of the highlights was being able to graph a rational expression. Rational expressions are just a function in the form P of x over Q of x. Here's some examples of rational expressions. Question? Yes. Maybe. Where'd they go? Yep. Anyone else in handout? That's a different class. This is your class, Wilma. Just go ahead and you can sign it, but maybe start it at the front. Any other? So on the first page, we talk about this notation of infinite behavior of a function. This is the first chapter in a calculus class. What is the function tending to as it approaches any given point, or infinity or minus infinity, right? Just kind of a show of hands. How many people did not watch the lecture? And just be honest, so I kind of know. So 1, 2, 3. So more than half the class. Okay, so in a sense, it's your responsibility to watch that. For the purpose of this quiz, I'm going to highlight some of the things that will definitely be on the exam in this section. In this example, we're looking at a function, and I can ask, as x goes to minus infinity, so I look at the graph, as it's approaching minus infinity, what is the function tending to? And the function is tending to 0, right? Because this is the output. So the notation here is x goes to minus infinity, the function goes to 0. You see that? That's what it's saying there. As x goes to minus infinity, the function is tending to 0. As x goes to 0 from the left, this notation here is from the left, right? So the little 0 to the negative power or 0 to the positive power, that's telling you which direction it's approaching this point. Right? And this is going to be very important when we talk about vertical asymptotes, if you have watched the lecture there. So here, this graph, as I approach 0 from the left, what's my function tending to? It's tending to infinity. It just keeps going up, right? Huh? So this is saying as x approaches 0 from the left, I'm looking on this graph, and I'll maybe pull up another example of this. I'm getting closer and closer to 0 from the left, but I never equal 0. So my output here is 2, 3, 4, 5, 6, 7, and I getting closer and closer to I'm approaching infinity. And I can plug in numbers. The graph of the function is 1 over x squared. Right? This is x. If x is a half, or a third, or a tenth, or 1/100th, and these are actually all negative. Because I'm getting closer and closer. I'm approaching 0, but I'm approaching it from the left. So I'm half, a third, a fifth, a 100th, 1,000th. It's getting closer and closer to 0, but I never hit 0. This would be 1 over a fourth, 1 over a ninth, 1 over 100, and so forth. These number, not 1, sorry. This would be 4, 9, 100, 1,000, because the negative is squared. 1 over a half is 2. 1 over a third is 3. So 1 over a third squared would be 3 squared, which is 9. But you should be able to see this from the graph. You guys see that as I'm approaching 0 from the left, I'm going to infinity. As I approach 0 from the right, I go to infinity. Let me pull up Alex. Question? So what, as x approaches infinity, what's the function tending to? A 0, right? That's infinity too, yeah. Because if I approach it from the right, I'm going to infinity. And that's what this notation here, to the left or the right.
Positive from the right, negative from the
Yeah, negative is mean you're approaching that point from the left. Positive means you're approaching it from the right, but you're never equal at that point. Because a lot of times your function is undefined at c. So I can't plug 0 into my function, right? 1 over x squared would tell me I can never plug in 0. Because we'd have 1 over 0, which is an arrow. So that tells me I have a vertical asymptote there. That's the next part of this section, is identifying vertical asymptotes. And 4 things can happen when you approach a vertical asymptote. You're either going to go to infinity or minus infinity. If you approach it from the left, you have 2 choices, up or down. If you approach it from the right, you have 2 choices, up or down. Right? So 4 different things can happen when you're approaching the function. When the function is approaching the vertical asymptote. So looking at a rational function, where the denominator equals 0 is going to end up with your vertical asymptotes, right? Vertical asymptotes are where the function is undefined. The graph doesn't exist at that point because you cannot divide through by 0. Does that make sense? So this example, g of x, if I want to find the vertical asymptotes of this graph, I have to factor the denominator. So I factor the denominator and I end up with a third and minus 2. So if I was to graph that, I would see at minus 2 and x equals a third is my vertical asymptote, right? That means if I have a graph on this side, I'm approaching this vertical asymptote. I'm either going to go like this or I'm going to go like this. And then I might do some other stuff. But I don't know what's going to happen. There's only 2 choices. As I get closer and closer to the vertical asymptote, I go to infinity or I go to minus infinity on the left. I go to infinity on the right or minus infinity on the right. So vertical asymptotes are pretty straightforward. You look at the denominator, you factor it. At the x value in which the denominator is 0 means the function's undefined. So that's a vertical asymptote. Any questions on that? So polynomials, we never had to worry about this because polynomials are continuous everywhere. There's no points of discontinuity. Horizontal asymptotes are another thing rational functions have. In polynomials, there's no horizontal asymptotes because it either goes to infinity, minus infinity, or plus infinity, minus infinity, or minus infinity, plus infinity, right? It goes on forever. Horizontal asymptotes occur, there's 3 different conditions when you have a rational expression, right? If the power in the numerator is greater than the power in the denominator, you have no horizontal asymptote. Which kind of makes sense if you think of an example. If I come over here and I have y equals x cubed over x, that's x squared. There's going to be no horizontal asymptote. The numerator is going to overpower the denominator, and it's going to go off to infinity or go off to minus infinity or minus infinity, positive infinity, or positive infinity, minus infinity, right? If the numerator is greater than the numerator is going to overpower the denominator. So you're going to go to positive infinity or minus infinity. If the denominator is greater than the numerator, you have a horizontal asymptote at y equals 0. And the easiest one to remember here is if you have a graph like 1 over x. If you memorize this graph, you find you have a horizontal asymptote at y equals 0. You can think of the denominator overpowering the numerator, and it's forcing the function to go to 0 on both sides. As x goes to minus infinity and as x goes to infinity, you have a horizontal asymptote at y equals 0. The third case, if the power in the numerator and the denominator are the same, they cancel each other out and they actually have a horizontal asymptote at A over B, where A is the coefficient of the numerator and B is the coefficient of the denominator, right? So let's look at these three cases. Here's examples. Where would my horizontal asymptote be in A? Would I have a horizontal asymptote?
Yeah.
Where would it be?
Zero.
Y equals 0, right? Because you can think of the denominator is overpowering the numerator and it's forcing the function to go to 0. So whatever's happening in the middle, my function is going to tend to y equals 0 on both ends. Make sense? No? So you kind of have to memorize these three cases. The power in the numerator and the power in the denominator, you compare them. Right? So here the power in the numerator is 2 and the power in the denominator is 4. If I plug in numbers, they're getting larger in the denominator faster than the numerator, right? So 1 over a large number is going to 0. The numbers are getting bigger in the denominator, so it means the whole function is getting smaller, right? In this case, my numerator is greater than my denominator. The power of my numerator is greater than my denominator, so my numerator is getting bigger, faster than my denominator. So my whole function is getting bigger. So do I have a horizontal asymptote here? No. Right. So horizontal asymptote. That means my function is either going to go off to positive infinity or go off to negative infinity. So I don't have to worry about horizontal asymptote. I don't approach anything. And then C, the power in the numerator is the same as the denominator. So I do have a horizontal asymptote, and that's y equals 8 over 2, which would be y equals 4. You guys see that? I take the coefficient in the numerator, divide by the coefficient in the denominator. If they're equal, they're going to cancel each other out, and the ratio of coefficient on top divided by coefficient on bottom is going to be my horizontal asymptote. Plug into the grid. We can have slant asymptotes, but generally we don't deal with slant asymptotes too much. And that's where we use long division or synthetic division if the denominator is a linear term, meaning x to the first power. Here we would say it has no horizontal asymptote, right? The power in the numerator is greater than the denominator, so it's going to tend to infinity or minus infinity. However, it's going to follow a line. And it turns out if I do long division, it's going to actually follow this line. As x gets really, really large, it's going to follow this 2x minus 1. So if I was to graph this function, what a slant asymptote means, so minus 1, and it has a slope of 2. As this function gets really large, it's still going to go off to infinity or minus infinity, but it's going to approach this line in some manner. It's either going to be on this side of the line or this side of the line. But it's going to still be infinity or minus infinity. But this is what's known as a slant asymptote. So slant asymptotes are actually from kind of 3.4 or 3.3 when we learn long division. So if I rewrite this expression, the quotient is a slant asymptote. So it's kind of the same approach as finding the quotient. Step 5 here, or objective 5, is actually graphing the rational expression. And your book is big on kind of giving you step-by-step kind of a table. You don't have to follow this step by step. As long as you find all the interesting points and test if it's above the x-axis or below the x-axis, you just connect all the dots. So it doesn't matter if you find the y-intercept first or the x-intercept first, or if you find functions above the x-axis or below it first, or the horizontal asymptote or the vertical asymptote. These are all each individual approaches. Putting it all together is actually going to graph it. So don't try to memorize this. Just think, what do I need to find the y-intercept? What do I need to do? What do I need to do to find the x-intercept? What's a horizontal asymptote? Is there one? Is there a vertical asymptote? And you kind of sketch it out, and then you look at the function. Is it above the x-axis or below it? And one thing you can do is plug in a point in the range between any zeros or vertical asymptotes, and the function is above it in that range, it has to stay above it. If it's below the x-axis in that range, it has to stay below it. So let's look at some examples. I'm going to skip this one. It's actually on your quiz. So do one similar. This is 3.5. Let's look at this function, and we'll do it a little more in depth. If I was asked to graph this function, right? So I might be given a coordinate system, and I say graph this function. What's some interesting things about this graph? Well, I might find where it crosses the x-axis, the zeros, right? The zeros are when the numerator equals 0. Does 10 ever equal 0? No, right? So there's none. I never cross the x-axis. Where do I cross the y-axis at? When x is 0, right? When x is 0, I have 10 over 6. Which would be 5 over 3. Right? If I plug 0 into this function, x equals 0, I would get 10 over 6. 3 times 0 is 0 plus 6. So this would be 5 over 3. So we'll just put this point as 5 over 3. Do I have any horizontal asymptotes? Where's my horizontal asymptote? Well, that's a vertical asymptote. We can do that. Vertical asymptote. Vertical is up and down, so that's going to be when the denominator equals 0. 3x plus 6. When does that equal 0? When x equals 2. So that tells me on my graph, at x equals 2, I have a vertical asymptote there. You see that? When the denominator equals 0, the function doesn't exist. So that means you have a vertical asymptote at that x point. Do I have any horizontal asymptotes? It would be negative 2. Yep, it would be negative 2. Thank you. Minus 2, because we have minus 6 divided by 3, which is minus 2. So, do I have any horizontal asymptotes? Power in the denominator is greater than the numerator, right? So my horizontal asymptote would be, the denominator would overpower it, right? And the function would tend to 0. Right? The power of the denominator, and you can think of a quick example, 1 over x. Right? 1 over x goes to 0 on both sides. 1 over 1,000 1 over a million is getting closer and closer to 0, right? 0.1, 0.001, 0.000001. So this function is going to tend to y equals 0 as x gets really large. You guys see that?
So if it was 10x over 3x plus 6, then the horizontal asymptote would be 10 thirds. 10 over 3.
Correct. Yes. If the power was the same in numerator and denominator, it's a over b, which in this case would be 10 over 3. You guys see that? You see the power of the x in the denominator is greater than the numerator? So that means the function is going to 0. Anytime your denominator is bigger than your numerator, your function goes to 0. When your numerator is greater than your denominator, your function goes to either positive infinity or minus infinity.
So when you sketch that, you would want that to kind of just drag like right
As
above.
it gets larger and larger, it's either gonna approach it on top
Right,
or on bottom,
right?
right? And here's what I was talking about in the region. So I cannot cross the x-axis.
Right.
The only where I can jump across the x-axis are at zeros. This function doesn't have any, or vertical asymptotes.
That's why you stayed above, because 5/3 would have to be, 5/3 would have to be -2 above, not below.
5/3 here
Yeah.
it's going to stay above.
Right.
Yes. So I know I have to approach this. There's only one approach here, right? Because I can't, from this point, I can't approach it because I can't cross that x. That's a very good connection there. So one thing I like to do that your book doesn't really kind of show, I like to make a number line, and I take f of x, and I like to put any interesting points on it. So zeros and vertical asymptotes need to be shown on the number line. And that tells me if I look at the function and I plug in a point to the left or in this region, any number that's less than -2. So let's plug in -5. I have 10 on top. -5 times 3 plus 6 is negative. It doesn't matter what number it is, as long as it's positive or negative. So I have a positive divided by a negative means my whole function's negative. And you can actually use your calculator and plug in -5 to see what it actually is and get a point. But all I care about, is it positive or is it negative? If it's positive, it means it's above the x-axis in that whole region. If it's negative, it's below the x-axis in the whole region. So in this case, it's negative, right? -15 plus 6 is negative. And then 10 in the numerator doesn't change. It's positive. So a negative divided by a positive is negative. So that tells me from -infinity to -2, I'm always below the x-axis. So I only have one choice. Function is going to approach it here and approach it here. I'm going to approach the horizontal asymptote from the bottom. Because I only have one choice. I'm approaching it from the bottom or the top. Right? But I know the function's negative. If it's negative in one point, it has to be negative in this whole region. Because they have no way to pop up above the x-axis. And like you said before, we already plugged in x equals 0. And that was positive. So I only have one choice there. So my graph of my function has to look like that. I have to stay above the x-axis in this whole region. So if I'm approaching this line y equals 0, I have to approach it from the top. You see that? Let's pull up another question. That's not going to be the exact one on the quiz. So this is 3, 5. No. Let's look at Let's look at graphing this one. So let's graph this function, g of x. Where do you want to start? See if there's any zeros. So how would I find zeros? So we want to see zeros of the function or vertical asymptotes. Vertical asymptotes are the denominator, zeros are the numerator of the function. So we'd have, where does 3x plus 3 equal 0? 3x equals minus 3. So x equals minus 1. That's a 0. So that means my graph at x equals minus 1, then y equals 0. My function equals 0, right? What's the next thing I might want to know about the function? Vertical asymptotes. So vertical asymptotes are a good thing to approach. That's going to be when x squared plus x minus 12 equals 0. X plus 4, x minus 3. So where are my where are my vertical asymptotes? At 3 and minus 4, right? So I have at x equals 3 and x equals minus 4. So the only places I can cross the x-axis or jump is at minus 4, minus 1, or 3, right? So if I just kind of do this on top, my number line, I have minus 4, minus 1, and 3. So what this is saying is anywhere in this region, if I'm above the x-axis, I have to stay above it. If I'm below it, I have to stay below it. You can see that? What would be another point on the graph I could find? I have any x-intercepts or vertical asymptotes. I mean, no, vertical. What about where it crosses the y-axis? I can plug in 0. So what happens when I plug in 0? I get, if I plug in 0, g of 0, I get 3 divided by minus 12, right? Because on top I get 3, on bottom I get minus 12, which would be minus 1/4. So that means I cross here. So this already tells me that I'm below the x-axis in this region, right? So I already kind of know that I'm going to approach this here. It's the only thing I can do. From this point to this point, I have to stay below the x-axis, so I can't turn around. So I'm only going to approach this vertical asymptote on this side. I can finish my signs of my function. So if I put up here, this is the sign. The sign tells me I'm positive or my function is negative. If the function overall is positive, I'm above the x-axis. So if I plug in a number that's less than minus 4, so let's plug in minus 5. And all I care about is positive or negative. Minus 5 times 3 minus 15 plus 3 is still negative, right? So the top is negative. Minus 5 squared is 25, right? Plus minus 5 would be plus 20 still. Minus 12 would still be positive. So I have a negative divided by a positive, which would be overall negative. You see that? Sometimes students struggle with positive or negative, so they just like to plug it in. What if I plug in minus 5? I have a negative x, negative whatever I get out. You can definitely do that in your calculator. But all I care about is it positive or negative? I know it's negative. -5, so my numerator's negative, but my denominator is positive. So overall, it's negative. So if I was to fill this in, the only outcome here would be this, right? The only way I can approach that horizontal asymptote, oh wait, sorry, I haven't done horizontal asymptotes yet. What is a horizontal asymptote here? Y equals 0 because the numerator is greater, or the numerator is smaller than the denominator. So in this region, right, I've already done this region, so I know it's negative here. So I know it looks like this. But what about from -4 to -1? I have two choices. It's either going to go up here or it's going to go down here. So I test a point. What's a point between -1 and -4? -2, right? So if I test -2, 3 times -2 is -6, plus 3 is -3. So the numerator is negative. -2 squared is 4. -2 is +2, but -12 is negative, right? So negative divided by negative tells me it's overall positive, right? So that means in this region, the function is above the x-axis. So that means that because this whole region is either positive or negative. From this point, I never cross the x-axis again until I hit here. So the whole one, I can pick any point in this region. I want to know, is it above the x-axis or below it? So I just picked -2 for this region. Here, from -1 to 0, I plugged in 0 and I got negative, so it has to be this way. If I plug in 0, I get a negative number. So I have to be above the x, or I have to be below the x-axis. So if I need to connect this point and approach this asymptote, and I cannot cross the x-axis, I'm either going this way or I'm going this way, depending if the function's positive or negative in that region. Huh?
Negative down, positive up.
Yes. If my function was positive, it means it would be above the x-axis
When you plug in the point.
when I plug in the point, right?
Or
So
plug in a number, yeah, okay.
here I plugged in 0 because 0 fell between -1 and 3. You will have to plug in 0 anyways because you need to know the y-intercept. You can only jump across the x-axis in between zeros and vertical asymptotes. And that's what this up here is telling you. Test point in those regions that break up the zeros and vertical asymptotes, and then that whole region is going to be positive or that whole region is going to be negative. So what about numbers greater than 3? Positive. So let's plug in 4. So 3 times 4 plus 3 is positive. 4 squared. 16 plus 4 minus 12 is positive, so I have positive divided by positive. So I have to approach this vertical asymptote, and I have to approach this horizontal asymptote. So approaching that, some of my functions are, I only have one choice there. You guys see that? So once you know it's above the x-axis or below it, you only have one outcome. You either approach it from below, or you approach it from above. You approach this going to infinity, or you approach it going to minus infinity. You cannot cross a horizontal asymptote when x goes to infinity or minus infinity. Any questions on that? Do you guys kind of see that? I'm going to pass out the quiz. We have a few minutes. I want this to be done in class. the sign-in sheet go around? Everyone get it? You guys get the sign-in sheet up here?